In this video, we are going to learn about the quadrilaterals. This video is an extension of quadrilateral which you have studied earlier, right? So basically, what is a quadrilateral? As we all know, quadrilateral is a four-sided structure which have, right? What does this quadrilateral mean? Quadrilateral is having four sides, four vertices, and four edges. Okay, everything is four in a quadrilateral. Like this rectangle ABCD, it is a quadrilateral because it is having four sides. Okay, so quadrilateral is a structure which has four sides, four vertices, and four edges, right? And next is, in this video we are just dealing with the properties of quadrilaterals, types of quadrilaterals, and their description was given to you in the previous videos, right? So in this we are just dealing with some important properties of quadrilaterals. So very first property of quadrilateral is sum of angles of quadrilateral is 360 degrees, right? If you are having four angles, this is, let it be a quadrilateral A, B, C, D, right? This is angle 1, this is angle 2, this is angle 3, and this is angle 4, right? So angle 1 plus angle 2 plus angle 3 plus angle 4 is equals to 360 degrees. Okay, it's just the double of a triangle. In triangle we have all the sum equals to 180 degrees, and in a quadrilateral we have sum as 360 degrees, right? Now see the next property. It says the diagonal of a parallelogram divides it into two congruent triangles, right? Two congruent triangles. We have learned about the congruency in the previous video. What is congruency? Which have similar shape and same size. So if I draw a diagonal over here in a parallelogram, two triangles are formed. First is triangle ACB. Okay, it will be congruent to triangle CDB. Okay, so this is a property of a parallelogram. Now the question comes is, what is a parallelogram, right? What is a parallelogram? Parallelogram is a type of quadrilateral in which opposite sides are parallel. Like if it is a parallelogram A, B, C, D, then AC should be parallel to BD, and this AB will be parallel to CD. Okay, opposite sides are parallel in a parallelogram. So this is a parallelogram. Now here comes the property of a parallelogram, that if we draw a diagonal, it divides the parallelogram in two congruent triangles. Now let's see the third property of parallelogram. Now these are the properties of parallelogram, right? In a parallelogram, opposite sides are equal. This was explained to you in the previous introduction videos of types of quadrilaterals, right? Where we introduced to you about parallelogram. Now in a parallelogram, opposite sides are equal. Okay, opposite sides are equal. Opposite angles are also equal. As we all know, if this is a parallelogram, okay, then the opposite sides as well as the opposite angles are equal. Opposite sides are AB is equal to DC and AD will be equal to BC. Similarly, opposite angles, which are opposite angles? Angle 1, angle 2, angle 3, and angle 4, right? Opposite angles are angle 1 is equal to angle 3 and angle 2 is equal to angle 4. Okay, opposite angles are equal and opposite sides are equal. Diagonal bisects each other. What does this mean? Okay, what is this bisect? If I say bisect, what does this mean? See, this is a diagonal and this is also a diagonal. If I draw two diagonals, then this will bisect each other. Bisect means equal halves. Equal halves. Okay. So, if they bisect each other and it is point O, which is the intersection point of two diagonals, then we can say OD will be equal to OB. Okay, this is the first diagonal which bisects. Bisect means divided into two halves, and OA will be equal to OC. This is first and this is second. So this means the diagonals are bisected. Okay, if bisect each other means they will divide the side into two halves, right? Now, if all these 3 points are satisfied with in any type of quadrilateral, right? These two are vice versa, okay? If any of these 3 points are true, then the given figure is a parallelogram. Like if its opposite sides are equal, opposite angles are equal, and the diagonals bisect each other. If these 3 points are satisfied, then we can say the quadrilateral given to us is a parallelogram. Okay. Next is diagonal of an rectangle. Now what is a rectangle? In which opposite sides are equal. Okay, they are not parallel, they are equal. B, C, D. We know what is a rectangle. In rectangle, AB is equals to DC and AD is equals to CB. So this is a rectangle, right? Rectangle is basically a type of parallelogram only, in which opposite sides are equal. See, in rectangle also the diagonals bisect each other. It's similar to parallelogram. Okay, if this is a rectangle, then this will also bisect each other. Okay, that means OB is equals to OD and OA is equals to OC. So this was about my fifth property. Similarly, we have rhombus. Okay. Now what's for rhombus? In rhombus, adjacent sides are equal. You know what is a rhombus? This is a rhombus. Okay. In a rhombus, diagonals bisect each other at 90 degree. Okay, the diagonals will bisect each other at 90 degree. Okay, this will be a perpendicular. These diagonals are not perpendicular or they'll not bisect at right angle, but in rhombus it will bisect each other at 90 degree. Similarly, square also bisect at 90 degrees. So we can say rectangle and parallelogram bisect each other. Okay, and they bisect each other in equal halves, and in rhombus and square they bisect each other at right angles. Bisect each other at right angles for rhombus and square. For rectangle and parallelogram, they just bisect each other. Okay, but in rhombus and square they bisect each other at right angles. Okay. Now let us move forward and see the other properties. See, it is a very important property. It's not about quadrilateral, it's basically for triangle. But in this property, when we prove this property, we use the concept of a parallelogram. So this is given to you in quadrilateral topic. Okay. A line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is half of it. See, let us understand with some few steps. Okay, if I am having a triangle, this is my triangle. It's triangle A, B and C. The line segment joining the midpoints. Let E be the midpoint of here and let F be the midpoint here. If I join the two midpoints, okay, it will be parallel to the third side. So my side 1, see, is AB with E as midpoint, right? Now my side second is BC. No, it's AC only, AC with F as midpoint. Okay. Now it says if I join the midpoints of these two sides, okay, what this theorem says, my side third is BC. So this theorem says that EF will be parallel to BC. First thing, this line segment EF will be parallel to BC. And the second thing is this EF will be half of this BC. So these are my two conclusions which comes out from this point, that the midpoints when joined in a triangle, it is parallel to the third side and this line segment will be half of the third side. The ninth is just the reverse of this one. A line through the midpoints of the triangle parallel to the another side and bisects the third. It is just the way of defining this point. Okay, this is just defining it into some different way. It's the same thing, these 2 points. The quadrilateral formed by joining the midpoints of the sides of a quadrilateral in order is a parallelogram. See, what does this mean? If I had a quadrilateral A, B, C, D, alright, if I join the midpoints, let it be the midpoint E, F, G, H. If I join the midpoints like this, this, this and this, so this structure, right, that is E, F, G, H is a parallelogram. If I join the midpoints, this has to be the midpoints, okay, then only we can say it is a parallelogram. So by these properties you can solve every question of this topic, and the very most important part of this chapter is the midpoint theorem, which were covered in point 8th and 9th. Thank you for watching.